Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello guys and welcome back to this amazing channel. This is Abhinav. Today we are back with our next problem of the day. Okay, which is nothing but in order successor or in BST. This is our next POD. So guys, please let me know if I'm clearly audible and visible to you all so that we can start today's class. So the problem is really easy. It's a easy problem which we will solve with a very basic method. Okay. So the problem says that we are having a BST, means a binary search tree, and we have to find the in-order successor for it. Okay. So let's say that we have an example BST here, which is, let's say, 10, 5, 17, 20, 15, 7, 9, 8, 6, 3, 4, 2. So you can see, guys, this is a BST where this is the root. Hi, Lakesh, hello. This is the root. Okay. Now, guys, what we can do here is we have to find a in-order successor. So in-order successor. So as we all know that in order of a BST is a sorted array. So for this particular BST, its in order will be 2, 3, 4, 5, 6, 7, 9, 10, 15, 17, and 20. Okay. So for each node, we have to find its in order, like for the given node. So let's say that the given node X is 5. So what is the successor of 5? Hello, Rishit, hello. Means the number just after 5. So the successor of 5 is 6. Let's say X is 15. So successor of 15 is basically 17. Just after it. So this is what we have to do. We have to basically solve this particular thing. Okay, we have to solve this particular thing. And if the node has no successor, like let's say X is equal to 20, it has no successor. So answer should be null. Is this particular thing clear to everyone? Is the problem clear? So guys, what we will do here, in this particular case, basically what we want a value which is just greater than X. Just greater than X. Am I right? A value which is just greater than X. So let's say if X is 10, answer is 15. If X is 5, answer is 6. So what we will do, guys, that we will take here a node. Okay, we will take here a node and we will call it as a successor node. Like in basically the node where we will store the answer. Okay. So let's take it. Let's say answer basically, okay, which is initially null. Okay, which is initially null. Now what we will do, we will take a while. So while our root is not equal to null, we will go on. Okay. Now if our root data is less than equal to our X data, we don't want less. What we want? So we want a value which is just greater than X. Am I right? We want a value which is just greater than X. We don't want a less value. We want values which is just greater than X. Am I right? We don't want less values. So when the value is less, we wanted a greater one. So greater means go on the right side. Go on the right side. And else, let's say the current value of data that we have is greater than X. Now what to do? So this is what we want. We want a greater value. We want a successor. So whenever this will happen, store that answer in a root, store that root as an answer, and still go for the left side, because we want just greater. We want just greater value. So let's say that we have got a value. Let's say for 5, 9 is also greater than it. For 5, 9 is also a greater value. But we don't want greater, we want just greater, means 6. So even when we have a greater value, check for smaller ones. Okay. And then at the last, simply return your. This is how, without any space complexity, with constant space complexity and order of log and time complexity, or we can say the height of tree, you can find this answer. Is this approach clear to everyone? This is how we are solving this particular problem. It was a really easy problem. Okay, it was a really easy problem. It is something similar to binary search. Just like we do in binary search, just like we found the upper bound of a function. Do you remember the upper bound? How we find the upper bound? It is exactly the upper bound. Like for 5, upper bound is 6. For 10, upper bound is 15. It is exactly similar to the upper bound that we find. It is nothing but upper bound in BST. Okay, great. So that's all, guys. That's all for this video. Okay, I hope that you have got it. Let's meet again next weekend, next Friday. Till then, thank you. Happy good and take care. GFG kar lo.